In this module, we're talking about reaction stoichiometry, using the coefficients in a balanced equation to give us some conversion factors. So, the coefficients in a balanced chemical equation give you a lot of conversion factors. I've listed for this particular reaction equation all of the conversion factors you get from the coefficients, but you almost always will just use one, and you don't have to write them down because you can just really read it off the balanced equation. But what these coefficients say is 1 mole of magnesium reacts with 2 moles of hydrochloric acid to produce 1 mole of magnesium chloride and 1 mole of hydrogen. So we get these conversion factors here. Look at them and see these numbers here. These are the coefficients. So 1 to 2 mole to mole ratio. Now, these numbers here, the 1, the 2, or whatever the coefficients are, these are exact numbers. They do not limit your sig figs. Remember that. So let's use these conversion factors. So let's say we have this balanced chemical equation here, and we want to know how many moles of zinc can be produced when we react 0.519 moles of aluminum with excess zinc sulfate. Now, excess zinc sulfate just means that we're going to run out of aluminum first, so that's what's going to determine how much of everything there is. So we don't have to worry. So we just don't have to worry about the zinc sulfate. So all we do is take how many moles of aluminum that we're starting with, 0.519 moles, and multiply by the mole to mole ratio. Now, the way we do this is we say that 2 moles of aluminum are equal to or produce 3 moles of zinc, and then when we come down here, we just look at what we have and make sure our units cancel. So the moles of aluminum are here. That means we have to have the moles of aluminum on bottom, so that puts the 2 here, and we get the 3 right here, right? Because the conversion factor was 2 moles of aluminum are equal to 3 moles of zinc. So we saw that moles of aluminum were here, we put it on the bottom, that gave us moles of zinc on the top. Anyway, so there's our answer. Now, most of the time, though, we don't have moles. We can't measure moles. We deal with things like grams. So, we do something like this. Same idea. It's at the heart of all this stoichiometry is the mole to mole ratio from a balanced chemical equation. So let's say we have this balanced chemical equation, and we want to know how many grams of water we can get if we react 5.199 grams of methane, which is this stuff right here, with excess oxygen. Again, the excess just means we don't have to worry about how much oxygen there is. There's more than enough. Methane will run out first, and that will determine how much of this stuff we make. So what we do is to use our mole to mole ratio, we need to know how many moles of whatever we're talking about we have. So the first step is, if you don't already have moles, which most of the time you won't, is you just convert grams to moles, and, or whatever you have to moles, in this case grams. And this, so we're going to divide by the molar mass. This is the molar mass of methane, CH4, and we get the moles, in this case of methane. Now we get to use the mole to mole ratio from the balanced equation. 1 mole of methane produces 2 moles of water. 1 goes on the bottom to cancel this. And this is how many moles of water. Now that we know how many moles of water, we just multiply by the molar mass to get the grams.